Welcome to the second video of the Cupertino Robotics Project CNC. In this case, we're going to extend beyond the first video a little bit, which fabricated a hole in a block. And what we're going to do is we're going to add a slot to that. So we'll have a block that's going to have a hole and a slot fabricated in it. This will runs in approximately 15 minutes. It takes about 15 minutes to go through it. As before, we really have to appreciate all those people who and organizations who made this happen. The Gene Haas Foundation, the Fremont Union Schools Foundation, and Tormach Corporation. They gave us the financial support for this. And then also we have to, we really want to thank Dassault Systems SolidWorks, providing us with the CAD and the integrated CAM solution that allows us to design and fabricate these parts. And then also for Doug Lowe for his help with the automatic tool changer, and of course Dave Isant for the custom tooling. And so the presentations we have, this is the second one, okay, hole with slot. And if you haven't done the first one, I really strongly recommend stopping now, go back to the first one, do the simple hole first, and then come back and join us with the hole and slots. This is really important to look at this disclaimer down here, and this disclaimer will continue throughout these. And this makes you basically familiar but dangerous in running a CNC machine. And so do not, and I repeat, do not attempt to operate our CNC machine without close supervision of a trained adult mentor. Okay, failure to follow this rule will not only endanger you, it may damage the machine, and of course it's against the first principles of gracious professionalism. So a simple hole, this will be a simple hole with slot, okay? We're going to drill a 250 thousandths hole, diameter hole, centered in a 500 thousandths slot. So the slot's going to be a width of a half an inch, and it's going to be an eighth of an inch, or 125 thousandths deep. And this will be in our 2x2 block. So basically we're just adding the slot into the original, into the previous example. We're going to use SolidWorks to add the slot to the hole, and then we're going to use SolidWorks CAM to create the CNC code with two features. So one feature is the hole, and the other feature is the slot. We're then going to download and run this on the CNC machine to create the part. So why don't we get on to the design? We continue some simple examples on how to use SolidWorks CAD and SolidWorks CAM to create the G-code for our Tormach 770M mill. And so we start, this is where we left off in the last video, simple 2x2 block, 2-inch by 2-inch block with a 1/4-inch hole in the center of it. Let's get something really complicated. I'm joking here. And we're going to do another sketch, and we'll do this as a face. And let me just get it. I always like flipping it up and get it there. And then I'm going to put another rectangle, and we're going to center it. Centered rectangle. And we're just going to put it across here. Let's see, how big do we want this rectangle to be? Let's pick up here. That would be a half an inch, let's say. So the rectangle's a half an inch. So we just did a sketch up here. What we're going to do is we're going to make it into a slot. So I'm going to go into my features, and I'm going to do an extruded cut. And the extruded cut is not going to be through all. It's going to, let's say, I'll make the slot Oh, let's go through and make it not a 1/2 inch, but let's make it, let's say point. Let's say we'll make it 1/8. Little 1/8 slot. Okay. So if we look at it now, we have our block with hole and slot. And so this is going to be no harder to do than the one with the hole. So we're going to pick up the, we're going to CAM, and so we're going to make sure that we pick up the history on here, and then we're going to define our machine first. And let's see, so far we have the machine. Let's go to the tool crib. Whoops, we don't have the tool crib, but if we select here, we get our standard tool crib. And then also remember, we have to make sure that we tell the CAM software do not add tools to our crib, because we don't physically have those tools. So we're going to get that. And then one other thing is we need the post processor. And the post processor, we go here, and we're going to get the Tormach running the Path Pilot software for our post processor. So we have this, and I think we don't need the other tabs, so we're good here. Okay, let's go through and see what our stock manager says about this. First of all, we want high density polyethylene rather than aluminum. Notice here that we only have 3 options for our lab. 6061 aluminum, high density polyethylene, or polycarb. It's just to keep things simple for what we do in the lab. And so the stock manager is good. Okay, we're going to select that. Let's get our coordinate system set. As before, our coordinate system coming out of SolidWorks is set in the center. I want to move it up into this corner. So the way we do it is we come down here and see where it says stock bounding box vertex. We click on that, and then we move our coordinate system over here. And remember, the X is going in the correct direction, but the Y and the Z are not. So let's go through and let's make the Z go up. So I go down here, select the Z axis, and I want the Z to be parallel to this edge. And so I do it that way, and it looks good, except the Z is going down, if you can carefully see it. So I'm going to flip it, and now it's going up. So let's double check it. If I put it in the mill looking like this, I will have the X going to my right, at positive X to the right, positive Y away from me in that mill, and Z is positive Z is pointing up in the mill. So we look like we're good on the coordinate system. Okay, let's do our setup, because we want to tell the mill how we put this thing in the mill, and we do not want the mill to think that the front plane is pointing up. So rather, we're going to tell it that this plane is pointing up. And so it's just that face up there. And by the way, we get this face also with it pointing up, so we're okay. So we got that. Okay, so I think we have all the pieces of the setup. Let's go over here and let's ask it to extract the machinable features. And there should be 2 machinable features. One is the slot and the other one's the hole. Let's see if I'm right about this. And guess what? We have a rectangular slot, and then we also have the hole as we had before. So far so good. So let's go and generate the operation path. And we generate the operation path. And notice what it does. It generates an operation path. This is simple. Drill, as we saw before, just pick up the drill and then just plunge it in. Okay, but this requires us to do a couple of passes on this. And so we do a pass that uses a 1/4 inch flat end mill. We do another pass that uses an 1/8 inch, and another pass that does the condor on the 1/8 inch. Now, the trick here is I don't think we need those 3 passes, but let me just go with those 3 passes right now. Okay, and then we'll come back and we'll do something a little bit fancy with them. Okay, so let's generate our tool path. And there's the tool path. Okay. and let's go through and simulate the tool path. And it didn't like this tool path. Over here, we got this one, we got this one, and we got the drill. Okay, so it skipped that tool path because it doesn't think we need it. So let's see what happens. So we're going to generate the tool path. Let's simulate the tool path as we did before. And so we're going to bring here so we can see the simulation. And so we're going to look at how the tool is going to move around. First, we're going to do the rough mill, the two rough mills, the contour mill, and then the drill. So we're going to simulate it. There's the simulation. We have the speed running at low speed, and then I'm just going to run it. Okay, that's the first one. It just goes back and forth as you would find in a conventional mill. Here's the second rough mill, which is, notice it's using the 1/8 inch, and it's smoothing out those corners in it. Now we drill the hole. So it didn't need the middle rough to make this thing work. So that's good. Okay, we can also now, because this is actually, it's moving around, we can do this, and then we could also step through the tool path. So here's the tool path, and it shows us how the tool path is going to behave. And so this is the tool path that's kind of plotted out for us. And you can see it in 3 dimensions as it's moving through. And so let me get it back. Ran away on me. So let's see how this tool path is going to run. So I'm going to go, again, I'm going to go at low speed. And there's the tool path. Zip, 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 boink. Okay, so we have these all drilled out, okay, slotted and drilled. So we got that, so I feel comfortable with having those. Now I'm going to do my post-processor. And I'm going to better give it a name. Let's see. I'm going to, I always do this. I'm just going to do it this way. Let's see. This is a simple hole with slot. And so this is going to save the G code into that, in that, okay? And so I'm going to have it produce the G code. There's the production of the G code. This is a lot more complicated. It's 2,000 bytes. So let's take a look at the G code in the editor. And this will run in 1 minute and 19 seconds. So it goes through, and this basically just, it tells you here's the rough mill using the 1/4 inch mill. That's the first one. And this tells it how it moves back and forth. This is the contour mill using the 1/8 inch mill for the slot. So that looks good. And then here's the drill as we had before, and it just plunged in and did it. So that basically is what we need to make this thing, to make this part. So hope this, you found some of this familiar, and I hope you're starting to build up some understanding of how this thing works. Bye-bye. We loaded the G code on the CNC mill, and we put the polyethylene block in the split bytes. And now we're ready to run the G code, and the first thing it's going to do is ask us to load T2, which is that 1/4 inch end mill. So you can hear us load T2. And now we push start, and it will do the rough cut for the slot. And there's one pass for the rough cut. There's another pass. We'll go down a little bit deeper. Back up, and then it's paused. The CNC mill has paused the program, and it's waiting for us to unload the T2, and then to load T1, and this will be for the contour mill. There's T1. It's that little 1/8 inch end mill. We press start again, and off the gun. And all of it do is just smooth out the edges. We'll just smooth out the walls of this slide. So let's smooth out to get slot. And now the CNC mill has stopped paused the program again, and it's prompting us to put in T45, which is the 250 thousandths drill, the quarter-inch drill we've used before. Here it is. And so we're going to put that in. And as soon as it's in, then we push start again, and it will finish the program. Again, we use that pecking motion, and we are done with